Hello mathematicians, welcome back. Today's lesson is going to be on the distance formula. So we've already talked about several other formulas like the midpoint and the slope formula. Today is the distance formula. So let's look at our objective real quick. I can use the distance formula to find the length or distance between 2 points. So this is what the distance formula tells us. It tells us the length of a segment or the distance between 2 points, which ends up being the same exact thing. So in this lesson today, we're going to do two things. First, we're going to derive the distance formula, and we're going to see how we can use what we already learned to do that. And we'll look at how to use the distance formula with several examples. I'll be doing one by hand, and the other I'll be using Desmos calculator step by step. Since we're doing digital learning now, it's best to learn it that way as well. So let's get started. So we want to look at how do we derive the distance formula, like how do we get it, what does it mean? So we'll use this as an example to see how we could do that. So I have a segment with endpoints 3, 3 up here and the point 0, -1 here at the bottom. And so what I want to do is find the length of the segment, in other words, the distance between these 2 points. And so I'm thinking, well, how do I do that? Because last time when we talked about midpoint, we know how to count a horizontal or a vertical distance. We can simply just count the squares going across or count the squares going up. But we can't really count squares diagonally. So what do? Well, last lesson, 1.5, we learned about a useful tool called the Pythagorean theorem, right? A squared plus b squared equals c squared, which we can use to find the missing side of a right triangle, whether it's one of the legs or the hypotenuse. And as it turns out, if we look closely at this shape, we see that we can form a right triangle. So the hypotenuse ends up being the distance that we want to find. And then here we'll have our A, and here's our B. So what we're looking for is our C. Now if I rewrite my Pythagorean theorem just a little bit and take the square root of this on both sides to get C squared to be just C, well, I end up with square root of a squared plus b squared. And I can use this to find the length of that segment, the hypotenuse. Now to find a and b is really easy. I can just count, right? Now you know how to do that. So we're actually going to take this a little bit further, and I'm going to ask you the question, what if I don't have the graph? What if I can't count? What if that's not available to me? So we need to figure out how we can use these coordinates to find the distance between them. Well, if you remember from our slope formula lesson, if I want to find the length of a horizontal or a vertical segment, sure, I can count the number of squares. But the other thing I can do is subtract the coordinates. I can subtract the coordinates to find horizontal and vertical lengths. Let's take this for example. If I want to find the horizontal distance between the blue point and the red point, well, I'm going to look at their x coordinates. So one of my biggest x coordinate here is 3, and I have 0 on my other x coordinate. So 3 minus 0 is 3. Now I can do the same thing for my vertical segment. Here I have 3, and I'm going to subtract it from -1. So 3 minus -1 gives me 4. So for my A, I get 3, and for my B, I get 4. Now if I want to verify that, 1, 2, 3, this checks out, and 1, 2, 3, 4, this checks out. So what we did was we subtracted the coordinates, right? Now I want to generalize this, which means I want to make it so I can use it with any coordinate points and not just this specific example. I know that here to find A, I subtracted my two x coordinates. So let's say one of these coordinates, I'll call it x2, and the other x coordinate, I'll call it x1. And for my y's, I'll do something similar. I'll have y2 minus y1. And this is exactly the same thing we did with the slopes, right? To find those horizontal and vertical distances, we subtract x2 minus x1 and y2 minus y1. Now remember, these are how we find A and B, right? Look again at my Pythagorean theorem and you see A and you see B. So what if I replace A and B here with these expressions where I'm subtracting the coordinates? Well, that's going to end up giving us C equals square root, and instead of A, I want to replace that with the x2 minus x1, which remember is the horizontal distance between our two coordinate points. And then I'll have that squared, don't forget the square. And then my b squared, remember that's my vertical distance where I subtracted the y coordinates, y2 minus y1 squared. Now all we have to do here is change this c into a d for distance, and I have the distance formula. So what I can do here to find the distance formula, first let's do the Pythagorean theorem. So I know that if I use c equals square root of a squared plus b squared, I can use this to find what c is. Now I already know that a was 3, right? Because we counted that. We get 3 squared. And then b was 4, so we get 4 squared. And so c equals square root of 3 squared 9, 4 squared 16, which ends up being 25. Square root of 25, and the square root of 25 is 5. So this is the answer we get from our Pythagorean theorem. Now, to verify this, let's see if I can get the same answer using the distance formula. And for this, I'm going to go to decimals. I'm going to drag this to the side over here. So I have them side by side. And so I'm going to start by typing in square root of x2 minus x1. Remember, x2 was 3. Well, first, before this, don't forget your parentheses. So 3 minus 0. And then I have the squared, right? And then plus another parentheses. Now I'll put in my y coordinates. So y2 is 3. Then minus negative 1. And then squared. And look, I get 5. So I end up getting the same exact answer either way, which proves that the distance formula here works. So this distance formula is the one that we'll mostly be using in these cases, because oftentimes we won't have that graph, so we won't be able to count the squares. So we're going to have to get used to using this formula. Now the easiest thing to remember, to make this as simple as possible, when you have your coordinates, label them. Label them x1, y1 and x2, y2. Let's go through some examples so that you can see what I'm talking about. So in this one, we want to find the distance between a, 2, 4, and b, 8, negative 4. Okay, so to start, again, what the first thing I want to do is label my points to know exactly which one is my x1, y1, which one's my x2, y2. Now remember, when I write my coordinate points, my x is always the first number and y is the second. So using this, I can see that in my first point, this will be x1 and this will be y1. Now whichever one is x1, y1 or x2, y2 doesn't really matter. But I always use the first point in the problem to represent x1, y1. Just because it's there, it's the first one, it's straightforward. And the second point I see will be x2, y2. So now I'm going to plug these numbers into my distance formula. So I have the square root, and then I have parentheses. Now I'm going to plug in my x2 minus x1. So x2, I know that's going to be 8. And then minus my x1, which is positive 2. And then don't forget the square. And then plus y2, which is going to be negative 4. So I'll put negative 4. And then minus my y1, which is positive 4. So minus 4. And then the square. Now, one of the things that I didn't do and I should have done was to write out the distance formula first. Because when we do that, we can see what coordinates go where. So I have x2 minus x1 squared plus y2 minus y1 squared. So always write out the formula first. I forgot to because I already know this by memory, but you guys don't. So it's very helpful if you write out the formula that you need in front of you. So that way you don't have to flip back and go and find it and then copy it back down. And by the time you copy it, you forgot what you wrote down. So you got to go back and yeah, it's a mess. So always write down the formula first. So that way you know exactly where these numbers are going to be going. Okay, so I've got that. So let's continue solving here. So I'm going to write d equals square root. Now I want to find out 8 minus 2. 8 minus 2 is 6. So I'll have 6 squared. And I'll keep this in parentheses, just out of safety so we don't get any numbers mixed up. Then plus negative 4 minus 4 gives us negative 8. And again, I'm going to keep that number in parentheses, especially when you have a negative number. Keep it in parentheses because the calculator is too dumb to recognize when you're trying to square a negative number. When you square a negative number, you should be getting a positive number as your answer. But I'll show you in the calculator what happens when you do that. So if I put in just negative 8 squared like this, you see that my answer still comes out as negative. That shouldn't happen. Anytime I square a negative number, it should be positive, like this. When I put in parentheses now, my answer is positive. So since I know that 8 squared is 64, I'll write that in. And then 6 squared is 36. And I have the square root of those two added together. So I add them together. 36 plus 64 will give me 100. And the square root of 100 is 10, which is my answer. So the distance between A and B is 10 units. Let's take a look at one more example. Now this example, I will do it all on Desmos calculator so that you can see how I break this down bit by bit. So that way if I have a radical that I need to simplify, I can do that on Desmos as well. So let's start with the question. Let's see. Find the length of segment DF, where D is negative 4, 7, and F is negative 10, 25. Big numbers, but don't get nervous, because remember, we have our distance formula. So I'm going to write it out this time. I'm going to write it all out. And I have x2 minus x1 squared plus y2 minus y1 squared. And I'm going to take the square root of all that. At this point, I'm going to label my x1, y1, my x2, y2, so I know which one is which. My first point that comes up are these, so I'm going to label those x1, y1, and I'll label these x2, y2. Now, like I said, I'm going to be doing this one on the calculator. So let me move this over to the side, and we'll be using Desmos calculator here. So the first thing we want to do is, when we're doing this in Desmos, what I like to do is to find first what the inside of the radical is. So in other words, what I'll be putting in the calculator is just whatever is inside the square root part. So I'll be doing this part only first. Now that doesn't mean that I'll do this part and that's my answer. It means that I'm going to do this first in the calculator to see what number I get. Now I like to put that in all together, but if you want, you can do this part first in the calculator and then this part second, and then just add them together. Take your time if you want. Nobody's rushing you. Remember, math is about getting the answer right, not about getting it fast. So what I'm going to do is I am going to put it in step by step so you can see what I do there. So let's start with the x2 minus x1 squared. Well, first I'm going to need my parentheses. So I put in parentheses. And I'll have x2, which I can see is negative 10. So minus 10. Then negative or minus x1, where x1 is negative 4. So I'm going to have minus negative 4. Then I close my parentheses and square, and I get 36. So that's going to be this part right here. So I'm going to put 36. Then I have my y2 minus y1. So again, I'm going to put parentheses. My y2 I can see is 25 minus my y1, which is 7. And then I'll square that. And I get 324. Big number, but don't let that scare you. So I get 324. Now the next thing I need to do here is add them, right? So I press enter. Now I have 36 plus 324. That gives me 360. So where I'm at right now is here. I have the square root of 360. Now if I type that in, square root of 360, oops, you see that I get this ugly decimal number. Remember, we don't like decimals in this class. We want to keep our answers exact. So that means that we're going to have to simplify this radical. We need to figure out first if I can even simplify it. So I'm going to keep the decimal answer here to compare it later in case I can simplify it, just to make sure I get the right simplification. So I'm going to take my 360. And remember, to simplify a radical, I need to find its prime factors. I need to factor it all the way down until the only thing I have are prime numbers. The best way to start is to start dividing by 2. And so I see that 360 divided by 2 is 180. So just to show you what I'm doing, I want to put some branches here, and I want to put a 2 because I know that 2 is a factor. So that gives me 180. So now I'm going to try to divide 180 by 2. And I get 90. So I know that 2 is another factor. So I'll put it on the list here. So far I've got 2 of the number 2. Now I'm going to try it again. So 90 divided by 2. And it works again. I get a whole number over here. So I can add another 2 to my list. Now I got 45, so I'm going to try 45 divided by 2, and this time it doesn't work because I get a decimal. So if 2 doesn't work, I'm going to try the next prime number, which is 3. And we see that 3 does work. So I'm going to put times 3 next, and then I'm going to try 15. So I'm going to try dividing 15 now. 2 doesn't work. What about 3? 3 does, and it gives us 5. So I'll put in times 3, and now I'm going to see 5. So 5 divided by 2, no. By 3, no. The only other prime number left is 5, and so that means 5 itself is a prime number. So that's as far as we can go. So I'm going to put in 5 here, 2. So my factors for 360 are 2 times 2 times 2 times 3 times 3 times 5. Now, if you want to do this by hand, all I really did was the same exact thing, but I just skipped all the branches. So what I had was 2 times 180, and then 180 is 2 times 90, and then 90 is 2 times 45, and then 45 is 3 times 15, and 15 is 3 times 5. So this is the exact same thing that I did over here. Just looks different, but it's the same because I have 3 of the number 2, 2 of the numbers 3's, and 1 5 at the very bottom. So the next step in simplifying this is to find all of the pairs of numbers that I have. So I'm going to be circling those. And I have a pair of 2's here. Then I have a pair of 3's here. And that's all the pairs that I have. So the next thing I'm going to do is I'm going to redraw my radical symbol, my square root symbol. And on the inside, I'll put the numbers that don't have any pairs. So like this 2 and this 5, I didn't circle because there's no pairs there. So I will put those inside the radical. I'll put a 2 and then I'll put a 5. And remember, if I have more than one number going inside, I'm going to multiply them together. Now on the outside, I have a pair of 2's, so I'm going to take exactly 1 2 to the outside. I have a pair of 3's, so I'm going to take 1 3 to the outside. Remember, if I have those pairs, I'm only going to take out one of those numbers. I'm not going to take both of them out. And again, if I have more than one number on the outside, I'm going to multiply those as well. So 3 times 2 is 6. Square root of 2 times 2 times 5, which is 10. I just said that. I do that a lot. And so our simplified answer is 6 times the square root of 10. Now just to double check that over here, we can have, first of all, 2 times 2 times 2 times 3 times 3 times 5. These are the same factors that I had over here, right? I'm just plugging them in to make sure that we do get 360, and we do. So now since I simplified it, I know that I have 6 times the square root of 10. That gives me 18.97. So let me type in square root of 360 again, and we see that we get the exact same decimal number. So what that tells me is that my exact form is correct. This exact form matches the square root of 360, so that means this answer is correct. And that's it for today's lesson, guys. Those are the examples. If you want more, please let me know. I'd be more than happy to help you out, help you understand this a little bit better. Again, make sure that you reach out to us, guys. If you have help, if you have questions, let us know. And please let us know if these videos are helping you as well. I would love to know what I can do to make these better, or if they really are helping you out, I would like to know that too. So please let us know, and if nothing else, I'll see you guys next time. Have a good day.